This is the second video for 4.6 or 3.7 in the 6th edition. And we're talking about horizontal asymptotes. So horizontal asymptote is really what we're looking at when we look at the end behavior, what the function does when x gets really big in the positive side or really far in the negative side. So a vertical asymptote is not part of the domain, so it cannot cross a vertical asymptote because it is not in the domain at all. But a horizontal asymptote, it could cross in the middle part. But what it can't do is, or what it does when x gets larger is then it approaches it. It can do lots of things in the middle of the graph. It can cross it many times even, but as it gets out farther, it approaches it. So it's useful for us to know what happens as the graph gets out there. So our very own library of functions reciprocal function has a horizontal asymptote, if you remember, of 0. And the way we look at that is we allow x to get like big, right? As x gets big, well, let's just even look at it. Let me make my unit size big, right? Like when x is 1, it's 1 over 1. But when x is 2, it's 1/2. When x is 3, it's 1/3. When x is 4, it's 1/4, and then 1/5, and then 1/6. So it approaches it, right? And the farther we get out, as x gets bigger and bigger and bigger, the closer to 0 it gets. Now in this case, it doesn't ever cross 0 because it cannot equal 0, right? And we had the vertical asymptote going on the 0. And, you know, it looks kind of the same idea down here, right? Where as it goes to the left, it approaches that horizontal line as x gets more and more negative as well. So what we look at is when we have a number over a variable and we let the variable get really big, that thing will get close to 0, right? So we can rearrange this. And don't get too excited about what I'm doing here. I'm showing you kind of the background. If you want to memorize the rule behind it, that's fine too. I'll tell you what it is. But let's just think about this. If I divided everything by 1 over x squared, okay? So top and bottom, I'm going to, or not divide, but I want to multiply by 1 over x squared on the top and 1 over x squared on the bottom. Okay, so I would have x over x squared plus 3 over x squared over x squared over x squared minus 5x over x squared minus 3 over x squared. Now, when I reduce that, I cancel an x and I have 1 over x plus 3 over x squared, and this I'd have 1 minus 5 over x minus 3 over x squared. Now here's what happens is, so now let's see, as x gets big, you know, first 10 and then 20, 100, 1,000, this is going to get close to 0. Well, this is going to get even closer to 0. So on top, I have 0. On the bottom, I have 1, and this would be close to 0, and this would be close to 0. So basically, I have 0 over 1, which equals 0. And And what this tells you, this will be true and this will happen anytime the degree of the numerator is less than the degree of the denominator. Because it just means the denominator is getting big faster. So if the top degree is less than the bottom degree, then the horizontal asymptote is the line y equals 0, just like in the reciprocal function. Okay? The top degree here is 1, the bottom degree is 2, so the horizontal asymptote is 0. So let me erase some of this stuff and we can look at how this graph will look. I changed my mind. I don't want to look at that graph yet. I want to look at the other kinds of horizontal asymptotes and then we'll do some graphs. Okay? So here's another rational function, and in this case, if you look, these are both of the first degree, right? So the degree of the top and the degree of the bottom are the same. And which really means, think about this. If you had x minus 4, and say x is 1,000, so we have 996 over 1,002. That's really close to 1. And the bigger you get, like 1,000,000 minus 4 and 1,000,000 plus 2, that's just really close to 1,000,000 over 1,000,000, right? So whatever, that the 4 and the 2, they don't mean anything when we let x start getting large. Okay? So the we can do it the same way we did before. We could multiply everything on the top by 1 over x. Okay, so I'd have x over x minus 4 over x over x plus 2 over x. This would go to 1 minus 4 over x, x, and 1 plus 2 over x. Now when I let x get really big, this would be 0 and this would be 0. So I would be just left with 1 over 1, which is 1. So the reason I got 1, and I'll show you in the next one again, but it's because this is 1x over 1x, so my horizontal asymptote is y equals 1. Okay, so that means that at the line y equals 1, it approaches it, right? It approaches it. Now we already partly graphed this in the last video. Remember that we had a vertical asymptote at -2, and we have a 0 at 4, and we had a y-intercept at -2. And remember that it looked like this, and I told you I was going to tell you what the end behavior did. Well, it approaches that line y equals 1. Over here to the left, we know it's positive, so we know it goes up here. We figured that out in the last one, and now it has to approach that y-intercept, that y equals 1, the horizontal asymptote, right? So that's kind of how it looks, where we're approaching this asymptote down here. We have to go through the 0 and approach the horizontal asymptote, and we approach the vertical and the horizontal on the left side too. Here's one more, and we'll just find the horizontal asymptote here. Notice that the degree of the top and the degree of the bottom are the same. They're both second degree polynomials. When that's true, we really just have to look at the coefficients of those leading terms. Okay? So, because if I were to divide everything by x squared, I would get 3 plus 2 over x minus 3 over x squared, 1 minus 3 over x minus 10 over x squared. All of these would go to 0. right? And I would just be left with 3. Okay, so you do not have to do this dividing by x squared thing. What you have to remember is that if the top and bottom degrees are the same, then you just have to look at these coefficients, and there's a 1 in front of the bottom one and there's not one. Okay, and it's the line y equals 3. Okay, and that's how we find a horizontal asymptote. Okay, here's one more we're going to look at. I think we have time to look at this one more before we do the quiz question. So, when you look at this, let's do all the things that we know. Okay, so first of all, domain. So to find the domain, we have to factor. Okay, so when we factor this, we do, let's see, we need things multiplied to be negative 12, added to be negative 4. So I've got 6 and 2, negative 6 plus 2. Okay, so that means the domain is everything except for 6 and negative 2. Okay, the vertical asymptotes. Well, neither one of those are repeated on the top, so those are our vertical asymptotes. The line x equals 6 and x equals negative 2. Now, our horizontal asymptotes. So now we're looking at what happens in at the ends, right? So I look at the degree. The degree of this first one is 1. The degree of the bottom one is 2. So the top is smaller than the bottom, means the bottom's getting big faster. So the horizontal asymptote is the line y equals 0. My zeros would be where the top is 0. So if I solve the top for 0, I would get 3/2. And my y-intercept, which you may notice is a lot easier to find from my original equation, it would be negative 3 over negative 12, which would be 3 over 12, which would be 1/4. Okay, so let's see if we can graph this. 4, 5, 6, 1 through 6. Oops, what happened? And through negative 2. Can't read my own writing. Okay, there's a horizontal asymptote, which is right on the 0. The 0 is at 3/2, which is right there. And the y-intercept is at 1/4, which is hard to write on this graph. And so if I were looking, I've already seen that this negative 1/4, oh, positive 1/4, sorry, it's a positive number. So I know it approaches up here. If I checked down here below negative 2, say like at negative 3, I'd get negative, negative, negative. 3 negatives makes a negative. So I know it approaches this way. After the 0 at 3/2, say like at 3, the top would be positive. Then I'd have a negative and a positive, so that's 1 negative. So that would be down. And finally, up here would all be positive, and it would look like that. Okay, so I know that was kind of a quick run through of the graphing. We'll do more graphing on the next video, and we'll do a lot more in class. So here's your quiz question for 4.6b. I just want you to find the horizontal asymptote of this function. It's a horizontal line, so write it in that form where it would say y equals some number. Okay, and put that into Canvas.